Hey, how's it going there, Algebra 2B people? So this week's lesson, um, it's not going to be that different from last week. So it should be, I hope, pretty smooth sailing in terms of, I hope last week went well because this one won't be that much different. It'll be just a little bit. Some of you will consider it more challenging. But anyway, here's what we're dealing with. So you can look at example 1 and 2 up here. I got them ready. And you can see by the title, this time we're doing exponential decay, which is fancy terms for exponential decreases. Where last week we were doing exponential growth, in other words, increase. What you would have noticed last week now is this number right here that see the exponent's still there, x. This number right here was bigger than 1 every time last week. The examples that I did for you on the last video, the first example, this number was 2, bigger than 1. This was 5, bigger than 1. And the last example that I had done with you, that value was 3.8. Yes, it was a decimal, but it was still bigger than 1. Now everything you're going to see in this week, this number will be less than 1, but bigger than 0. It doesn't go smaller than 0, and it doesn't actually go to 0. So 1/2 is between 0 and 1. They will be between 0 and 1. 1/5 is between 0 and 1. And I'll do a third example as well, where I use a decimal value instead of a fraction like this, just so you get the idea. Now, some of the rules we laid out last week are going to be similar, but they're going to be we're going to have to approach them differently. So if you remember last week, I said start, picking your x numbers and get the y number to get close to 10. And then I said once you get close to 10, use one negative number and call it good. Well, that's going to be reversed this week. We're going to use one positive number and then go to the negative numbers, trying to get close to 10. And you'll see what I mean by that in just a second. So here we go. Notice I've set up both tables already because you always start with 0. And we actually will go to 1 next. But let's start here. From last week, anything to the 0 power is 1. So 1/2 to the 0 power, still 1. Now, if I go to the first power, a 1 here. 1/2 to the first is 1/2. Or 0.5 if you want to call it a decimal. But the point is, that's already small. See, remember, we used the negative number last week to get something small. This week, the small number will come from the positive 1. If I were to go to 2, just to let you know, 1/2 to the second power would be 1/4 or 0.25. Even smaller than that. We don't want smaller decimals anymore. So immediately after 0 and 1, we go right to the negative exponents. And I'm going to get you set up right away because that'll make the video shorter. Now I explained this to you last week, that negative exponents, I just a very quick blurb about it. Negative exponents mean reciprocal, change the exponent to positive. So just a quick note, if you were to take a calculator and do 1/2 to the negative 1 power, it's going to come up 2. And I know if you actually had a calculator in your hand and did that, you'd be like, what? Why is it coming up 2? Because 1/2's reciprocal, flip it over, is 2 over 1, or 2, and you change the exponent to the positive, so from negative 1 to positive 1. Folks, 1/2 to the negative 1 means 2 to the first. That's why it's 2. If you did 1/2 to the negative second, it would be 2 to the second, which is 4. If you did 1/2 to the negative third, it would be 2 to the positive 3, which is 8. So this is why if you had a calculator in your hand and you actually did 1/2 to the -1, 1/2 to the -2, 1/2 to the -3, you get the numbers 2, 4, and 8 because it's taking this reciprocal and changing the exponent to positive. So now we plot those points. 0, 1 being right there. 1 and 0.5. 1 to the right, 0.5 up. See? Just like last week. We will not cross the x-axis. We get close and just, I think the word I used last week was just hover above it. Plot these other ones. This is -1, 2. 1 left, 2 up. That one's 2 left, 4 up. And then 3 left, 8 up. And you see that decrease? See, from left to right, decay, decrease. It's downhill from left to right. Same, it's a reverse shape of last week. Last week, this side was low, and it curved uphill drastically. Well, now it comes downhill drastically, like so. Okay, so this week, because this number right here is less than 1, you can expect the shape to look like that each time. Okay, here we go. Moving on to the next example. 1/5 to the x power. We start with 0. Anything to the 0 power is 1. 1/5 to the 0 power is 1. This week we will only go 0, 1, and then go to the negative numbers. 1/5 to the first power is 1/5, also known as 0.2. 1/5, 1 divided by 5 is 0.2. See, that's small. We don't want anything smaller than that, so we go negative exponents. Folks, if you check 1/5 to the -1 power, you get a 5. And again, remember that reciprocal idea is going, what's 1/5's reciprocal? Flip it over, 5 over 1, 5. So 1/5 to the -1 is technically 5 to the +1, 5 to the first. Now, I'm going to warn you ahead of time. I'm going to check -2, and I'm going to be crossing it out in a minute because it's going to be bigger than I want to graph. 1/5 to the -2 is 5 to the +2, 5 to the second. That's 25. That's too big. We saw that last week. We crossed it off. So we're going to graph this with 3 points. Here we go. 0, 1. 1.2. That's really low right there. And then -1, 5. And you can see that steep. Now, understand, -2 is supposed to be up 25. So this is drastic here. Like, this is really steep. And then just comes on down here, hovers above that x-axis. Okay, so I have one more example for you. I'm going to pause so I can make some space, and I'll be right back. Okay, so here we go. Final example. This time, notice I used a decimal, but that decimal right there is still less than 1. That makes this same left to right downhill shape about to happen. Follow the same rules. We'll start with 0. Anything to the 0 power, still 1. So 0.37 to the 0 power is 1. We'll go to the first power. Anytime this number is less than 1, we only go 0 and 1 and stop. 0.37 to the first power, 0.37. And see, 0.37 is small, so we're good there. Now, if I actually need a calculator to help here because 0.37 is not an easy reciprocal to deal with. So when I do 0.37 to the -1 power, I get about 2.7. So I'll put that in there. And I'd like to get a little bit closer, a little bit bigger. I like to get closer to 10. So if I do 0.37 to the -2, as you see I already got -2 in my chart ready to go, that comes out 7.3. Now, just for the sake of argument, I'm not going to put it in the chart, but what if I did the negative 3? 0.37 to the negative 3 power, that's 19.7. Yeah, we're not graphing 19. So 7's good enough. We can plot those points. Okay, 0, 1, right here as it always is. 1.37. That's like right there. Again, really low, really close to the x-axis. Negative 1, 2.7 is about right there. And then negative 2, 7.3 is like right there. As long as this one's between 2 and 3 and this one's between 7 and 8, 1, 2, 3, 4, 5, 6, 7, 8. So that's good. And you see, same shape as this one, basically. So down here, hover, and then swing back through here, up. All right, so there you have it for lesson 6.1, exponential decay. Yeah, we're just taking this in short strides, we're not trying to overwhelm anybody, just doing kind of small amounts of work each time, and I think that's reasonable. There's a very common theme for this week that you should be able to handle. And remember, if you say, I don't have a calculator, there are calculators available on your Chromebook. Like I said, Desmos is one that I know a bunch of the math teachers use. So download Desmos and use that online calculator. All right, take care of yourselves, everyone.